You spend hours cleaning your engine bay. You buy special soaps, industrial degreasers, expensive brushes, maybe even a pressure washer. You spray everything down, scrub every corner you can reach, rinse it off, step back, and somehow there's still grease hiding in places you can't get to. Most people assume that's just part of the process. Engines are dirty. Cleaning them is difficult. That's the way it has always been. But here's a question. How do you think people cleaned engines in 1943? No pressure washers. No foam cannons. No specialized detailing products. No YouTube tutorials explaining the perfect engine bay cleaning routine. Just machinery that absolutely had to work. And somehow, engineers at Porsche came up with a solution that was surprisingly clever. Most people imagine old vehicles as crude machines. They picture oil leaks, dirty engines, and mechanics simply accepting that everything would be covered in grease. But that picture isn't really accurate. During World War II, military vehicles were expected to operate under conditions that would destroy most modern cars. They drove through mud, dust, rain, snow, and terrain that constantly coated engines and mechanical components with grime. Failure wasn't an option. A broken-down military vehicle could stop an entire operation. Reliability mattered more than comfort, more than appearance, and sometimes even more than speed. Porsche, which many people know today for building sports cars, was deeply involved in military vehicle development during the war. The company worked on projects that included the Type 100 tank and the Ferdinand, later known as the Elephant tank destroyer. These machines were enormous, complex, and constantly exposed to contamination. Naturally, they needed maintenance. And maintenance meant cleaning. The obvious solution would have been water. After all, that's what most people still reach for today. Water seems like the universal cleaning tool. It's cheap, available almost everywhere, and it works well on many types of dirt. But water creates problems. It gets trapped in tight spaces. It promotes rust. It can damage electrical components. It can remain hidden inside machinery long after the surface appears dry. The Porsche engineers understood something important. If grease is the problem, why use something that doesn't naturally mix with grease? Think about how most people clean an oily pan in the kitchen. The water doesn't remove the grease by itself. The soap is doing the real work. The soap breaks the bond and allows the grease to be carried away. The engineers approached the problem from a different angle. Instead of fighting oil with water, they used oil-compatible solvents. Rather than trying to wash grease away, they dissolved it. The process was surprisingly simple. A light petroleum-based solvent would be applied to the contaminated surface. The solvent would penetrate and break down thick grease deposits. Workers would agitate the area with brushes or cloths. The dissolved contamination could then be wiped away. Afterward, the solvent itself would evaporate, leaving very little residue behind. No water. No drying process. No rust concerns. No hidden moisture waiting to create problems later. At first, the idea sounds almost backwards. Using an oil-derived product to remove oil-based contamination seems counterintuitive. But chemistry often works that way. Many substances dissolve best in materials that are chemically similar to themselves. The heavy grease effectively merged with the lighter solvent, making it much easier to remove. What's fascinating is that this concept never disappeared. In fact, it's still being used today. Aircraft maintenance often relies on solvent-based cleaning methods because trapped moisture can create serious issues. Marine applications use similar approaches in situations where corrosion is a major concern. High-end electronics manufacturing frequently avoids water altogether because sensitive components can be damaged by even small amounts of moisture. In other words, some of the most advanced industries in the modern world still use principles that engineers understood decades ago. That's what makes this story so interesting. We often assume technological progress moves in a straight line. New automatically means better. Old automatically means outdated. But reality is usually more complicated. Sometimes older engineers were solving problems under severe constraints. They didn't have unlimited resources. They didn't have advanced equipment. They couldn't simply buy a new product every time a problem appeared. They had to understand the problem at a deeper level. The Porsche engineers couldn't afford corrosion. They couldn't afford maintenance delays. They couldn't afford machinery sitting idle while someone waited for water to dry. So they looked at the challenge differently. Instead of asking, how do we wash away grease? They asked, how do we make grease disappear? That subtle shift changed the entire approach. And honestly, that lesson extends far beyond engine cleaning. A lot of modern problem-solving starts with assumptions. We see what everyone else is doing and immediately follow the same path. We use the same tools, the same methods, the same solutions. We rarely stop and ask whether the underlying assumption is correct. Water seems obvious because we've always used it. But obvious solutions aren't always the best solutions. Sometimes they create new problems while solving the original one. Sometimes the answer looks strange at first. Sometimes it even looks wrong. Yet those unusual approaches can end up being far more effective. That's why the story of Porsche's wartime cleaning methods is still worth talking about. Not because it reveals some secret miracle product. Not because it's a forgotten piece of magic engineering. But because it demonstrates a different way of thinking. The engineers looked at grease and decided not to fight it directly. They chose to dissolve it instead. Simple idea. Powerful result. So the next time you find yourself standing over an engine bay with a bottle of degreaser in one hand and a hose in the other, struggling to remove stubborn grime, remember that engineers 80 years ago faced the same challenge under far tougher conditions. They had fewer tools, fewer resources, and far less room for error. Yet they still found an elegant solution. Sometimes innovation isn't about adding more complexity. Sometimes it's about removing the wrong assumption. And sometimes the smartest answer has been sitting in history all along, waiting for someone to notice it again.